Alright, everybody. We are doing a camera off stream today because I am in a weird place and also it's past midnight. Um, so I probably should be asleep, but I am streaming still. Partly because I can't get to sleep, but partly, and I can't stress this enough, I did not finish the problem from last time. I was not very happy about it. Not really happy that I got stuck on the problem, despite trying twice. But now, I'm pretty sure I got the right strategy. So we are going to continue working on this problem and hopefully get it done by tonight. Okay. So here's the deal. Here's where we're at. We left it. We have a pretty interesting strategy coming up. So the idea is as follows. We start with the left and the right, and we say, all right, we are going to for one of these, we are going to get his sort of best partner, right? We're gonna find best partner. I'm gonna call this the best partner approach. So we'll start with left and right at their widest. We will pick the shorter line. Sorry, we'll pick the taller line actually, and find their best partner. And so I want to accompany this strategy with a bit of a proof. I want to prove. Start with left and right at widest, and we're gonna. So the plan is sort of progressively move the left and right pointers towards the middle to get narrower and narrower container until they cross each other. All right. Once they cross each other, we know we're done. And so the idea is as follows: we want to move these pointers, but at the same time, we want to make sure that whatever line that we skip over is guaranteed to be not part of the solution. Okay. We're guaranteed to not be part of the optimal solution. If you have, let's say your left and right pointers are here, like 0 and 8, and you want to move from 0 to say 3, you have to guarantee that 1 and 2 cannot possibly be part of the optimal solution. If it is, then you're wrong. Then that's a problem. Alright, so the way I'm going to do this is we're going to pick the taller line and find their so-called best partner. Alright, and so the way this works is that anybody who we skipped in this best partner process is guaranteed not to be part of the optimal solution, because proof. Let's say optimal left and right are and well L prime and R prime. Okay. When we skip a line, we skip one of the lines while searching for best partner. We know where we skip cannot be L prime or R prime because either for the best right, then we cannot be R prime, because either L is L prime, which means L is the optimal line. In which case, then whatever optimal line we select would be R prime. If it's not L prime, if the left is not already optimal, then there exists a pairing yeah. Anyway, I'm pretty sure this is correct. Okay, so find their best partner. Okay, now you have these two. Now you have to find the best partner for the other guy. Now we have to find the best partner for the other guy. Okay. Okay, you know what? I'm gonna do the following. I'm gonna cheat a little bit. I am going to call this max area 1. And I know this is a slow but correct. This is slow but correct, right? So I'm gonna do define max area I'm gonna try the fast one, and then I'm gonna write this other function that will test whether max area and max area one are always the same. So let's see what this strategy is. You know what? I spent too much time writing and talking. I'm just gonna write some code and see how it works out. So left equals 0, right equals length of height minus 1, while left is smaller than right. Best order equals 0. Max. Now we're gonna see if left is larger, smaller, and right. We're gonna keep going until the pointers cross. Okay, so we're gonna pick the shorter one. So if left if height of left smaller than height of right, else. Okay, so let's do the move the left line first. See what happens, and we're gonna improve and refactor our code later on. So if height of left is smaller than the height of right, so we're going to see if we can find something that improves. So now we're gonna say while left is this is harder than I thought. Yeah, it's kind of hard to be talking and writing code at the same time. Actually, it's kind of hard to be talking and doing something productive at the same time. But we're gonna see how it works. Okay, while left is smaller than right, left plus equals 1, so increase it by 1. So my water equals to calculate water left, right. Equals to calculate water left, right. If my water is greater than max water, then I'm going to break out of this. Left equals to L. I'm going to break out of this. Okay. So we only care. We only care if the height is smaller, is greater. Right? If the height, if the new potential L is even shorter than the current one, then we don't have to calculate at all. We know obviously it's going to be less because you get a narrower container with a shorter height. Okay, so this will move the left. This keeps moving left until it gives you a better max water. My water equals to max water. Okay, and what happens if my water is less than? Actually, I may not even have to do this. I may not even have to do this. I may be able to just do this. Because this is actually slower. Oh my god, am I stuck again? I might be stuck again. You know what? That's fine. It's okay to be stuck. It's not fun to be stuck, but it's okay to be stuck. So left smaller than right. I'm going to move the height. I'm going to move the short one. If I go to a taller one, I'm just going to pick the tallest one. If this is already taller than everybody else, so it only matters if I go to a taller one. And then actually I shouldn't do this. I should keep moving it until I find one that's not just taller than my current one, that is taller than my current one. Or is taller than the other one. Wait a second, will this work? So I'll check if my height is taller. If it's the same, I'll move the right. Okay? And the right is minus equals 1. Let's see what happens if I run this. Will give me the right answer. Oh. Next quarter. Pretty sure I'm going to get the right answer. Oh, I don't have to overthink it. Okay, so basically you start from left and right. You move the shorter one, because you move the taller one, it's not going to improve, right? So you can only move the shorter one. So you move the shorter one. You move the shorter one, and there's no way. Okay. So why does this work? I see. I think this will work. So why I think this will work? Because when we move a line, the line we move is guaranteed to not be in an optimal solution. Why? Because the line we move, we only move it if the line that we're moving is shorter than our current one. Or short, if it's shorter than the current one, we don't have them to check, right? Yeah, I'm pretty sure this is. If it's shorter than our current one, we don't have to check at all. If it's taller than our current right, but shorter than our current left, we'll have to check. It might be a new candidate. It might give us more water, right? If it's taller than the other one, we never get into a case where somebody that we skip over could have been a better solution than the one we have. Okay, I'm pretty sure this is correct. So instead of just submitting, I am going to test. I'm actually going to test this. And the way I'm going to test it is going to create a new how do you create a new object? Like this. So random test case is basically, so what I want to do here, okay, so now that I have a solution, I'm pretty sure the solution is correct, but now I want to take some time and go through the extra step of actually testing the solution. And so what we're going to do here is we're going to do randomized testing. So randomized testing is not foolproof, but because I'm already relatively sure that my solution is correct, randomized testing is generally good enough to give me a sense of, what's probably correct. I will not be able to detect very bizarre edge cases or find these pathological cases. I still have to think them through. So generate a random array integer. I'm pretty sure I can do that easily in Python. Okay, so it turns out this thing is fairly easy. So just return randint 0 10 means, pretty sure this is 0 to 10. Let's just look at this. Okay. So I don't want 0, I actually want 1. And let's say 20. And this would be, let's say 50. the 50. This will give me enough cases. For I int range 100, we'll do this 100 times. Tests case equals ren in equals to generate random case. So why do I use a separate function here? Why don't I just type this out directly? That's going to save me a few lines. Yes, but I will argue that that is not as readable as reading this, because, and that's a little bit subjective, but here I make it clear right away that when I am generating a random test case here. At some point in the future, I can come to this function here and change how the test case is being generated. The person reading this piece of code does not need to know how this random test case is being generated. Right? If I had written randint 12050 here, it will take that person another second to say, oh, what's this thing doing? Okay, it's creating a random array. Oh, I see, it's creating a random array to be used as test case. Whereas this one makes it crystal clear. Of course, there's the other side of the argument. There are some people who say, hey, if you make your code shorter, you don't. There is the other side of the argument that says, okay, well, now if I do want to know how these test cases are generated, I have to go somewhere else. I can't just see that test case generation strategy right there. As done. So next area. Area test case not equals if I'm going to be less ambitious here. So let's just say 10 and 10 to make it. Let's see how this goes. So, test. Let's run it. Actually, I'm not sure if I can do this. Forgiven. What the heck? Randint? No. Why does it say forgiven? Okay, let's see what Google says. Random.renint. So is there renint? I say random.renint. Let's try this. Is it going to tell me to import something? Exactly 3 arguments, 4 given. Oh, it doesn't allow me to generate an array of random. So this is actually wrong. Generate random array of integers. How do I generate a random array? So I don't want it to generate just one number. I want to generate a random array. So it says size equals to 5. Maybe it says, maybe this is this a Python version thing? Or is it a NumPy thing? So it's math.renint versus NumPy.renint. I think this has to do with, maybe it has to do with NumPy. I'm not sure. Maybe I'll just explicitly import NumPy at the top. Okay, so this actually works. But this may not work. Let's try with an empty replit. You can see I've not done this in a while. This is Java. I need a Python one. Okay, how do I go back to where I was before? So let's create a new replit. And then run this. It should run. Oh, all passed. Look at that. Let's check that out. Okay, so this thing passes. Let's try something more ambitious. 1120. This might take a while. I regret my life already. Let's try this. All pass. Okay, excellent. Will this still finish? Okay, the reason why I'm doing this. Okay, just to make sure that this thing is correct. Okay? We're going to do this. And hopefully this will not pass. Yep. This will not pass. Alright, cool. So this thing actually works, which is great. It makes me happy. But I want to know how much better is Max 1 is my algorithm compared to the other algorithm. So I'm going to do Python time function. So I think the easier way to print elapsed time is just start time minus end time. Okay, so time.time. So we want to time a function. So we're going to write a function that times a function. We're going to call it fun. Well, it's actually not a function, it's an executable. Right? So the difference between a function and executable, a function is a procedure to be called. An executable is actually calling that thing. Okay? So we're going to actually call that thing. I don't actually remember how to do this. Start equals time.now. I think it's now. Let's just check what it is. It's time.time. And equals time. In the meantime, we'll do exec. We'll run exec. Oh, exec is a special keyword. Just call it x. Then we'll return results equals will return results comma time and minus start. Okay, cool. So it looks something like this. This is a time function. What are you complaining about? Read definition I use. Okay, I think this should work. So we're gonna say time me. We're gonna create a lambda. Lambda is a thing. Lambda is a thing that you can actually execute. Okay, so this is kind of advanced. Lambda, this. So if my result is not equal to result, I need to keep talking. Find something to say. Okay, my time equals my time. Okay. Total my time equals to 0. Total time equals 0. So total my time plus equals my time. Total time plus equals let's just call it A time. Okay, so we're gonna run this. We're gonna see okay, so let's run it. So I used a grand total of 0.08 seconds. Wait, then what happened to all the other time? And brute force used 2 seconds. So I used brute force is going to take a while. It's going to take 6 seconds. Okay, so I will say that the difference between this and this is 24 times. You'll notice that as this number goes down, the difference between the two is going to shrink. This is only 6 times. Whereas if this goes up, then the difference between the two will grow. And the reason for that is that this might run out. This might run out of resources. Oh, it didn't run out of resources, but it was like 33 times. $33x. Okay, cool. So that's great. So that shows then my strategy actually works, which is great. And that also allowed me to find out that you actually can't do certain things in Python. Okay, so how else can we optimize this? Well, it turns out that we can still optimize this even more, just a little bit. You see this height left smaller than height right, so you move the one that's shorter. Well, it turns out that so every time you move it, you calculate water. So it turns out that if well, it turns out if the old height is smaller than the new height, you don't even have to calculate water. Yeah. So there are certain optimizations you can do, but the optimization honestly is quite small, so I'm not going to do it. Instead, I am going to submit my code. I'm pretty sure this will be the right answer. Let's see if it's accepted. Accepted. Beats 10% of users with Python. Beats 18% of users with Python. Oh man, it's still slow. I feel so bad about this. I want to be faster. How do I make this faster? So I'm going to check if I don't have to do the subtraction each time. Don't actually have to do this. How do you do if labs right else right? I'm trying to make this a little bit faster. I'm just trying to make this faster. Okay, so I'm gonna make it so that I don't have to calculate. Short left. I don't think this is going to make a difference. I seriously doubt this will make a difference. Wrong answer? This should be the right answer. But it's still the same. Wow, it's wrong answer. Why is it so slow? Why am I so much slower than everybody else? I can't figure this out. Is it because I'm delimiting the height too much? No, it's not. Or is it just because I'm using this calculate water? Is it because I'm calling a function? Let's see if this is the case. Might be. What? Why is it still so slow? So you're still faster than me. Why? Where's the time going to? Isn't this as fast as it gets already? How does this get any faster? Don't tell me it's the array delimiting. Where's the time going to? I'm convinced that there's some black magic here. How can this be wrong? HR. Because either way, this gets updated, right? Minimum of height left times height right. Height minus equals to 1. This is correct. So H left. I'm convinced that this is. HL versus H. God damn it. HL versus H. I see. So this should be correct. HL versus H1. Yeah. Is it faster? It's not faster. God damn it. Where's the time going though? I want to see what other people do. Multiply height by width. Oh, this is exactly. Wait, this is exactly what I wrote. How is this different from what I wrote? What the heck? This is crazy. Okay. Is this going to be... I mean, is this going to be faster than what I wrote? Did I beat 20% with Python? No! How? I don't get it. Wait, how? Okay, let's see. Okay, beats 100%. No, I just don't believe you. 100% faster solution with beats 100%. How do you beat 100%? Wait, while... Is it the min? Is it the min that's killing me? Wait, is it the min? Min is it because of min? min is the one that's killing me. Because this guy has no min. Oh, oops. No, it's still slow. Why? No way. Beats 100%. Are you sure you beat 100% with this? Java, C++. Where's the Python code? Run. No, this is still slow. It's the same speed as mine. No way. This is. No way. This is. I'm not believable. How can it be? Okay. Well, either way, I think that's all we're gonna do for tonight. Sorry, this live stream has been really rambly, and I also spent 1 hour on this. I didn't expect to spend 1 hour. Either way, I'm gonna go offline. So thank you everybody for watching. See you next time.